This is for Year 12 methods that involves the division of polynomials with remainders. The first is a cubic divided by a linear. So I'm dividing the x plus 3 into x cubed plus 2x squared plus 4. X goes into x cubed, x squared times. So I put my x squared there. X squared times x gives x cubed. X squared times 3 gives plus 3x squared. I'm going to subtract the second from the first, so I just put in my minus signs. X cubed minus x cubed is 0. 2x squared minus 3x squared is minus x squared. And I have a plus 4. X goes into minus x squared. Minus x squared divided by x is minus x. So minus x times. Negative x times x gives minus x squared. Negative x times 3 is minus 3x. I subtract the second from the first. I have minus x squared plus x squared is 0. Nothing minus minus is 3x and plus 4. X goes into 3x 3 times. 3 goes into x. 3 times x is 3x. 3 times 3 is plus 9. Minus the second from the first. And I end up with minus 5 as a remainder. Therefore, this equals x squared minus x plus 3 minus 5 over x plus 3 as a solution. Notice that in here, when I didn't have an x term in the top bit, I had 0 minus that to leave 3x. The second example involves a quadratic divided by linear, and a similar process occurs. X minus 3 goes into x squared plus 7x minus 5. X goes into x squared x times. X times x is x squared. X times minus 3 is minus 3x. Minus minus. 7x plus 3x is 10x minus 5. X goes into 10x plus 10 times. 10 times x is 10x. 10 times minus 3 is minus 30. 10x minus 10x is 0. Minus 5 plus 30 is plus 25. Therefore, x squared plus 7x minus 5 over x minus 3 equals x plus 10 plus 25 over x minus 3 as being the solution. The third example involves a quadratic divided by a quadratic. Same process, x squared plus 1 divides into x squared plus 4. X squared goes into x squared once. 1 times x squared is x squared. 1 times 1 is plus 1. Subtract the second line from the first. You end up with 0. 4 minus 1 is 3 as a remainder. Therefore, x squared plus 4 over x squared plus 1 equals 1 plus 3 over x squared plus 1 as being the solution.